DeepMind controls nuclear fusion with reinforcement learning. Yann LeCun proposes a new architecture for world models. And according to a reliable source, it may be that today's large neural networks are slightly conscious. Welcome to ML News. It's Monday. Stop. Let me tell you about a feature that I have just learned about recently, and it's crazy. This video is sponsored by Weights and Biases, and they have this alert thing that you can send yourself emails whenever your runs finish, whenever your runs crash, and at your own choice. So if you log your experiments with Weights and Biases, and if you don't, you should, in your code, you can simply put this alert statement right here, and that will send you an alert as soon as that piece of the code is reached. I mean, for some things, it's obviously helpful to pack that into some sort of an if statement, but you can send yourself updates about your runs. This way, you won't have to check them constantly, so you can keep track on the go. If you go to your account settings, you'll see that scriptable run alerts are already activated. That means whenever you put the alert statement inside a code, it will actually send you an alert. This works whether it's in a script, on a server, or in a Jupyter notebook. Now, you can also activate notifications on email or on Slack whenever a run finishes, or if it crashes a certain amount of minutes into the run. This is super helpful if you are dealing with various problems such as nans appearing after a while and you don't want to keep constantly checking your runs. This could really help you. As I said, these notifications will show up in your email inbox or in Slack, and they even have different levels as you may be used to from logging statements. So this is an absolutely cool method of keeping track of your runs without having to check. If you go to this URL, wannabe.me/Yannick, then you'll get straight into the documentation of the alerts. Please check it out. There's also a collab to go along with it, showing you directly how to use this thing. And it's most beastly when you combine it with configuration frameworks, such that if any run exhibits any suspicious behavior, you can immediately get an alert to see what's up. Thank you so much to Weights and Biases for sponsoring this video again. Weights and Biases is your one-stop shop for ML ops. Whether you're a researcher or in industry or a student or just someone who's doing this at home for a hobby, they have something for you. Personal use is free forever. And please check out the link to learn more about their awesome alerts feature. Let's get into the video. All right, we have a lot to get through today, so buckle up. The first story, DeepMind has a new blog post called Accelerating Fusion Science Through Learned Plasma Control. Now, this is insane. They control plasma in a nuclear fusion reactor using deep reinforcement learning. So this thing is a research apparatus called the Variable Configuration Tokamak, and it produces this thing called plasma inside of it. Now, the goal here is to generate and control this plasma over time, which would allow us to harness the energy of nuclear fusion. How exactly? I'm not sure, but it's important that we can do it. Yet controlling this thing is really hard. There are a number of magnetic coils that are super strong that go around and inside of this device. And decisions about how to steer them need to be made in very short time. And this is a highly nonlinear complex problem. So DeepMind used a simulated environment in which they trained a reinforcement learning policy in order to steer these coils. This augments the traditional control system that was already in place and allows them better controllability of this plasma. This is really important because if the plasma is mishandled, like if it touches a wall or anything like this, that can cause a lot of damage to the apparatus. Now, hold on right here. Are you telling me that deep reinforcement learning, this thing, or, that thing right here, Yeah, that controls a nuclear reactor. Absolutely fantastic. Oh, yes, please. More plasma right here. Yeah, more plasma is gone. Well, in any case, they do actually achieve stable configurations of plasma, including ones that the human controllers couldn't do before, such as this droplet configuration on the left. There is a paper in Nature to go along with it, and this represents a significant step towards making nuclear fusion more plausible for possible future energy source. The Google AI blog has a piece called Good News about the carbon footprint of machine learning training, in which they analyze how they've reduced the carbon emissions of machine learning training in the last years. They have this principle called 4M, which stands for Model, Machine Mechanization, and Map Optimization, into which they categorize the various things that you can do to make your machine learning model training use less energy and therefore emit less carbon. This starts by figuring out smarter model architectures themselves, by using more efficient machines, by pooling machines into data centers where you can cool them very effectively, and then by locating these data centers on the planet where energy is maybe more green or more readily available and emits less carbon as such. They say these 4 practices can reduce energy by 100x and emissions by 1000x. It's pretty cool. They have a plot right here, and no, these aren't carbon emissions. These are actually reduction in carbon emission. I know the plot is a little bit weird, but a Y value of 1 would be the 2017 state, and then, you know, reduction. Now, at least part of this comes as a response to a different piece of work by the University of Massachusetts, which completely overestimated the carbon emissions of a previous work by Google on neural architecture search. So Google had this paper on an architecture called the evolved transformer, which they found by neural architecture search. One of the goals of the architecture search was to build a more performant, more efficient model, which the evolved transformer is. So this external study had estimated the cost of doing this architecture search. And it turns out, according to Google's own numbers, they overestimated the amount of carbon emissions by 88 times. That's an 8,800% error rate. What's even crazier is this right here. They say, unfortunately, some subsequent papers misinterpreted the NAS estimate as the training cost for the model it discovered. So the study was criticizing the architecture search itself. Now, given the fact that you do architecture search, you can actually waste some resources because you're gonna get them in again once you use the discovered model if it's really that much better. But apart from that, they did criticize the architecture search. They overestimated by 88 times, and now other papers come in and they just misquote the study, and they claim that the estimate is the cost of training one evolved transformer model. Google writes, in reality, training the evolved transformer model on the task examined by the UMass researchers following the 4M best practices takes 120 TPU v2 hours and costs $40 and emits only 2.4 kilogram of carbon dioxide. That is an error rate of a factor of 120,000. Now, I'm not saying there's nothing to be worried right here about the cost of training large machine learning models. There certainly is. And within Google, they say that machine learning uses about 10 to 15% of Google's total energy use, split into 3/5 for inference and 2/5 for training. So that's not nothing. There seems to be a narrative about big companies bad, which I get, understandable, but still, if the desire to complain becomes stronger than actually looking at true numbers, the criticism might be a bit misplaced. And yes, these big companies train larger and larger models, but they're also building more and more effective data centers, and these larger models could potentially, down the road, save a lot of stuff and advances beyond the need for carbon-based energy much faster. But I have one issue with this article. Whoever thought it was a good idea to call this thing Good News about the carbon footprint. Like, could you make a title that any more screams lobbying piece? It's like some Christians at your door. Have you heard the good news about the carbon footprint of machine learning training? I mean, the title here almost invalidates the article itself, but I'm gonna believe them on their numbers. The Meta AI blog, which surprisingly is still hosted at ai.facebook.com. Wait, the certificate is made out to Facebook Inc.? They never changed their name? It's all just a big conspiracy? The metaverse isn't real? In any case, the Meta AI blog has a new post called Yann LeCun on a vision to make AI systems learn and reason like animals and humans. And other than implying that humans apparently aren't animals, it details a new vision of a broad architecture guidelines for building the next generation of autonomous intelligence. Now, diagrams like these have existed for a while, the different modules that we need in order to interact with the world, in order to build autonomous systems, but the specific focus here is on the green bubble called world model. And the main ingredient LeCun suggests here is called JEPA, the Joint Embedding Predictive Architecture. Now, this pulls together a number of threads that Yann LeCun has been pursuing and advocating for in recent years, such as energy-based models, such as self-supervised predictive learning, and he advocates strongly for using regularizers instead of contrastive learning. Now, all of this by itself is of course nothing new. Meta, previously Facebook, has investigated all of these things in a number of architectures, which have been really successful, but to get it together into one model is sort of a suggestion by LeCun, and he says they haven't built this model yet, but it is a plan on the horizon. The cool thing about this model is it can be composed. For example, it can be made to do short and long range predictions. It can do supervised as well as unsupervised, as well as reinforcement learning tasks. It can be arranged in a temporal and hierarchical fashion to learn layers of abstractions and build up plans into the future. Focusing on world models is definitely a breakaway of other reinforcement learning efforts, which directly try to go model-free from input and perception to action without having some sort of an intermediate model. Now, if this all seems pretty vague to you, then yes, it's just a plan for now, but it sounds pretty cool. Yann LeCun has also given an extensive talk about this, which is on his YouTube channel. Yes, Yann LeCun is a YouTuber, bet you didn't know that. So leave a comment right here if you would like me to make a dedicated video about what we know so far about the JEPA architecture and how it might work. Researchers from the Max Planck Institute of Neurobiology publish a paper called A Biophysical Account of Multiplication by a Single Neuron, investigating a real neuron, biological neuron, in a fruit fly that can do multiplication or something akin to multiplication, which is really cool because a lot of models and what we knew so far about neurons were always dealing with sort of input-output linear relationships. So we could weigh inputs and we could add them, but we could not necessarily multiply them, or there wasn't necessarily a mechanism by which that could happen. These researchers study fruit flies under different visual stimuli and discover that under the right conditions, they can see a multiplication-like nonlinear behavior in a neuron. If you want to learn more about this, check out the paper, it's on Nature. Lilian Wang publishes Emojisearch App, which is a pretty neat search tool where you can find emojis. Pickle. Yeah, works nicely. So the code of this is online. It essentially does a call to the OpenAI API, gets embeddings from the new embedding endpoint, and then compares those embeddings of whatever you entered to the embeddings of a predefined list of emojis. Pretty simple application of the embeddings API, and works pretty well for the stuff I've tried. If you want some inspiration, check it out. We've previously reported on arXiv, which is a pendant to arXiv, where you can view any paper as an HTML page instead of a PDF. And we're happy to report that arXiv is now an official sub-project in the arXiv labs. So hopefully pretty soon you'll be able to have a unified experience across arXiv where you can go to a website instead of a dumb PDF. Ilya Sutskever has tweeted out, "It may be that today's large neural networks are slightly conscious." And the whole world came crushing down. This, to me, is essentially kind of a shower thought. And just, it's Twitter. You just tweet it out. It's a musing. It's an interesting thought. It may lead to an interesting discussion. Who knows? However, the world seemed to freak out about it. And I just can't understand that people legitimately get mad at this. Like, either you're looking to get mad at something, or you're just so far down some rabbit hole of construing this as bad. I don't know. Now, of course, there were legitimate responses and people discussing this in seriousness, but then also the news happened. Futurism.com. OpenAI chief says advanced AI may already be conscious. Interestingengineering.com. OpenAI top scientist says AI might already be conscious. Researchers respond furiously. Furiously, you hear? But there were some brave souls coming to help. Another one from Futurism.com. MIT researchers don't ignore that possibility that AI is becoming conscious. Daily Mail. Artificial intelligence expert warns that there may already be a slightly conscious AI out in the world. Oh no. And interestingly, you see the phenomenon that happens often with media in that they just kind of translate the may and could to OpenAI co-founder Ilya Sutskever claims artificial intelligence is conscious. Experts called out his claim as being off the mark and called him full of it. Like, the word experts has got to become a meme sometimes in the near future. Like, as soon as you start a sentence with experts say, it's like, who listens? Nobody listens, especially if their argument is you're full of it. The convincingness. Oh no. Gee, I've just meditated 3 days about the metaphysics of what could and couldn't be consciousness and the inner workings of deep learning. But now that you're saying I'm full of it, that does it. Thank you, experts. Again, futurism. Researchers furious over claim that AI is already conscious. They're mad. Oh no. They're mad. Anything but mad, not the mad. And the Daily Star. Conscious AI may already exist as expert receives backlash over terrifying warning. Well, there you have it. I personally have no stake in this. I just found it funny how the media reacted right here. If you want my opinion, and this is not me coming up with this by myself, it's held by a lot of people, is that consciousness, whatever it is clearly a physical process that happens somewhere in the brain as a result of matter interactions. And therefore, it's absolutely possible that there is something like consciousness happening in a non-human brain system. Secondly, I think consciousness is not something that is binary. It's not like you're either conscious or you're not. Most things in biology are not that clear-cut. I mean, even the concept of alive is sort of undermined by the existence of viruses. And I think the two qualifiers here, first the it may be, and second the slightly conscious, work very nicely with that. Now, of course, a lot of people are pointing out that we don't actually have a good definition of what consciousness is. We don't know too much about it to be able to make these kinds of statements, which is absolutely true. Guaranteed. However, very often those are the same people that say, absolutely not are large neural networks conscious. And it's like, well, which one do you want? In any case, carry on. There's a new paper by Meta AI and INRIA claiming that vision models are more robust and fair when pre-trained on uncurated images without supervision. So what they've done is they've gone out into the internet and they just collected, without any filters, a humongous amount of images. No processing, no filtering, and they've just trained the models on those images. And it turns out on a lot of these metrics about fairness and robustness, that model performed better than models that were trained on curated datasets such as ImageNet. Now, of course, this is interesting because it cuts directly against the people that claim, often very loudly, that you need to heavily curate your input data, you need to heavily curate your training process. Otherwise, the models, they will become oh so bad because they'll pick up all of these stereotypes and all of the biases in the training data. And while I generally agree with that statement, the evidence here seems to be that exposing just the model to a wide variety of data and the diversity of data may actually achieve that in practice. And if you ask me, I'd rather go with the people that actually tried it out and measured it, rather than the people who are simply claiming we should do something and how it would turn out. On a more philosophical level, I think that, much like humans, we shouldn't shield our models from bad material. Instead, I think we should expose our models to all sorts of material, all sorts of inputs, and then build the types of models that can actually reason across those inputs and reason why particular things in particular contexts may be appropriate or inappropriate or warranted. And yeah, that's just my opinion. Leave yours in the comments. This project is pretty cool. CLIPasso is a system that comes out of a paper, and it uses CLIP together with a differentiable renderer for drawings, in order to create sketches of pictures in various levels of abstractions, as you can see right here. Most notably, this process is based on CLIP and does not require a sketch dataset to be present. And because the sketches are parameterized as Bezier curves and not pixels, you can do things like change the brush styles and use all kinds of weird things that you can do in vector graphics as opposed to the classic pixel graphics. Check out their project website. It's pretty cool to see what the model outputs, and yeah, give it a shot. All right, here's our section of helpful things. First helpful thing is this book right here. Natural Language Processing with Transformers by Louis Tunstall, Leandro von Vera, and Thomas Wolfe. Now, what's interesting about this book right here, other than it might be interesting to a lot of you, is that this one comes with a dedication. It says, "Hi Yannick, have you heard of them Transformers already? We think they're pretty cool. Maybe you'll learn a thing or two about them in this book." The book itself goes into concepts of how transformers work, how they operate on language, but also the direct code examples of the Hugging Face library. So essentially an all-in-one tutorial on natural language processing in 2022. Thank you very much. The book is available on Amazon as an ebook and also as a, well, paper. I think it's called paper. So, you know, give it a try. All right, some more helpful things. tbparse is a library that parses TensorBoard events. Very cool. If your stuff outputs these event files that you want to read with TensorBoard, but you actually want to import them somewhere else, this may be the way to go. Anomalib is a library for benchmarking, developing, and deploying deep learning anomaly detection algorithms. AKB48 is a database of articulation objects. These are objects that you can somehow interact with by articulation. So books, bottles, knives, dispensers, compasses, glue sticks, nail clippers. So this is a database of properties and 3D models of those things. Evosax is a library that contains JAX-based evolution strategy algorithms. This library is by Robert Lange. You might know him. He's a writer in the ML space, and it implements a number of different evolution strategy algorithms in JAX. Related to this, Google releases EvoJAX. Yes, the previous one was EvoSax. Now it's EvoJAX. This is hardware-accelerated neuroevolution. Now, EvoJAX focuses on the acceleration, the distribution, and the efficient methods of rolling out episodes in neuroevolution algorithms, while EvoSax focuses on implementing the actual strategies. Now, what's cool is that Robert has already made a pull request to EvoJAX, and the two projects are integrated with one another. So if you're into evolutionary algorithms, give these two projects a try. TextlessLib by Meta AI Research is a library for textless spoken language processing. That's essentially NLP without an intermediate text representation, going from sound waves directly to whatever the task output should be. StandardSim is a synthetic dataset for retail environments. So this is a rendered dataset of stores, like the inside of stores. It's pretty cool. And it looks like super real, except it's too clean. Like, it's way too clean. Patrick von Platten tweets that new T5 checkpoints are to be found in the Hugging Face hub. This is after research by Tai and others who trained a lot of T5 checkpoints in various sizes and analyzed their scaling properties. So now there are a number of T5 checkpoints that are potentially much more performant than the original ones. They are available in large and small, especially one is called T5 Efficient Tiny N18 or NL8. Who knows? But it does require less than 100 megabytes of memory, which is very small for a transformer. ModSynth is, by its own description, a huge dataset for pedestrian detection and tracking in urban scenarios, creating by exploiting the highly photorealistic video game Grand Theft Auto 5. So yeah, GTA 5 in-game footage is now used to create high-quality datasets. This is how far we've come as a civilization. Better hope Sasquatch isn't in there. HashNerve PyTorch is a pure PyTorch implementation of the paper on neural graphics primitives. So neural graphics primitives, or instant NGP, was a paper by NVIDIA that made it possible to render nerves a lot faster. Now, that implementation was only available in C++, so the researchers here have ported it to PyTorch, and that is not as fast, but it allows researchers to play around with it. Diffrax is a library of numerical differential equation solvers in JAX. They're auto-differentiatable and GPU capable. Excellent. FinRL is a deep reinforcement learning for quantitative finance. If you ever wanted to predict the stock market using deep reinforcement learning, don't do it. It doesn't work. But for anything else, use FinRL. The AI Nordics Discord is releasing Swedish models. Specifically, there is BERT Large Swedish Case, which is BERT trained on Swedish. Excellent. They also have a GPT model in Swedish, but they're only giving it out if they like you, because of potential misuse of the model. Well, I guess whatever floats their boat, yeah. MLD is a benchmark about long documents and multitask learning. It's a set of 6 NLP tasks where the input consists of at least 10,000 words and has various tasks such as translation, summarization, question answering, and more. Interestingly, there seems to be tasks where you need to create an output that is even longer than the input text. Breaching is a framework for attacks against privacy in federated learning. So federated learning is this idea that users kind of keep their own data and just kind of send you back gradients for your models. And there are a lot of techniques that claim that this can be done with privacy sort of guaranteed, that I can send around my gradients without the central instance being able to reconstruct my personal data. So this framework includes a number of what's called gradient inversion attacks that allow you to do it nonetheless. So it's a little bit like the field of adversarial examples. If you're interested in this kind of stuff, this might be a cool way to start. Metashift is a dataset of datasets for evaluating contextual distribution shifts and training conflicts. So this is a benchmark about distribution shifts, and one thing it does, for example, it presents objects in various different contexts to analyze how models react to that. For example, on the bottom here you see a cat on a keyboard, in a sink, in a box, with a remote control, just cat things. So it's really cool that we go beyond sort of the classic one image is one object of one class setting and take the next steps in order to deploy these models in the wider world. All right, that was already it for helpful things. Well, not already. That was a lot of helpful things. Our last story for the night, The Verge writes, the US Copyright Office says an AI can't copyright its art. Now, if you click through, you'll get to an article of Urbasm, and for whatever reason, their background picture has a bot in it, but okay, cool. But this turns out to be about an old friend of ours. It's Dr. Stephen Thaler, the inventor of a system called Dabus that makes autonomous inventions. Apparently now it also makes art. Now, Thaler has previously applied for patents of inventions that his system has made and actually succeeded in some countries and failed in others. Now, apparently he's also trying to patent his art. Sorry, the AI's art, of course. Now, I've looked into his systems and they seem kind of sketchy, to the point where I'm not sure if these are just kind of sort of pixelated versions of things that exist, and that's just disturbing. I mean, that's just an image of Einstein overlaid on a tunnel, but yeah, Dr. Thaler seems to be on a mission to establish that AI can own patents, but he's now been smashed down by the Copyright Office that says that in order to grant a patent, there must be a human intervention. So their definition of patentable creativity includes essentially the interaction of the human intellect or the human brain with the world. Now, that is the law currently, but who knows how this goes on in the future? It's a difficult question because for the first time, probably, it is probably legit to ask who owns the copyright of AI-produced stuff, and whether or not this counts as an invention, and then who made the invention. And if AI is capable of being an inventor, what kind of implication does this have down the line? It's a set of interesting questions, but I don't have the answer to those. Let me know what you think. As always, this was it for ML News. It was wonderful to have you here. Please check out Weights and Biases, 1db.me/Yannick, and I'll see you next time. Bye-bye.